Hello and welcome again as we consider yet another multiple choice question for IB Chemistry. A voltaic cell is made by connecting two half cells represented by the half equations below. And here you have manganese accepting 2 electrons to form solid manganese, and lead in aqueous solution also accepting 2 electrons to form lead solid. First of all, one of the sources of confusion that students sometimes have is manipulating these equations to arrive at cell potentials, because here both the manganese and the lead are gaining electrons. Reduction is gain, oxidation is loss. So both of these as written, and this is the way it's written in the IB Chemistry data booklet. In fact, this is the way that standard electrode potentials are written. They are always written as reduction potentials. So here you have both species being reduced. But in an actual cell, only one of them would be reduced and the other one would be oxidized. Now, how do you figure out which one's going to be oxidized and which one's going to be reduced? That too is a source of confusion in many textbooks, but there's a simple way. Looking at the two half equations, which are both written as reduction potential, you have to look at the value here for the standard electrode potential, and the one that is more positive out of the two, that is the one that prevails and has reduction happening. The other one, that is going to undergo oxidation. So in effect, you'll be using its standard oxidation potential, which is the reduction potential in reverse. And that's why you have this reversible sign here. So looking at these two, the green one for lead, that is a higher value or a more positive value than negative 1.19. So lead is going to be having reduction. Lead is going to be the cathode, which is where you have reduction always, whether it's a voltaic cell or an electrolytic cell. And at the anode, you are going to have oxidation. Manganese solid is going to be going this way, and the oxidation potential for manganese is going to be positive 1.19, because you'll be following the reaction this way, and lead is going to be going this way. And once you have that kind of reasoning, that something has to be oxidized, something has to be reduced, you're always given reduction potentials for both of them. The one that is going to be reduced always has the higher of the two values. And here this is just less negative than this one. Sometimes, of course, it's an actual positive value. So that this stays this way. The standard electrode potential, again, is always written as a reduction potential. So to get the oxidation potential from that, you've got to reverse it. And it comes to 1.19. So now we can look at the answers. And for A, it says manganese is oxidized. And yes, we've said it's oxidized because it's going this way. Oxidation is loss. Going this way, it's going to lose 2 electrons. So that is correct. And then the voltage of the cell is 1.06. Well, once you've changed this to an oxidation potential, which is 1.19, and this stays as its reduction potential, which is negative 0.13, all you do is you find the sum of both of them. So positive 1.19 plus negative 0.13 is going to be 1.06, and therefore the answer to this question is A.